Welcome to all my farms to DB Tuitions. This is your tutor doctor. So we are going to talk about organic chemistry part 2 in this series. Today we are going to talk about types of formulae. Now, in organic chemistry, whether you're in year 10, year 11 or year 12 and you're learning this topic, before you delve deep into the topic, it is very much important, just not in organic chemistry, but also what are the kind of formulae. So this requires your previous knowledge of knowing molecular formula. Now, what is molecular formula? The first one we are going to look at. So since your journey into science from year 7, you might have learned formulas of various compounds such as carbon dioxide, methane, sulfuric acid. So carbon dioxide is CO2, methane is CH4, sulfuric acid is H2SO4. What does this show you? For example, let's look at carbon dioxide. So whenever you're writing your molecular formula, this is showing us we have one carbon atom and 2 oxygen atoms. So carbon dioxide is made of one carbon atom and 2 oxygen atoms. This molecular formula is showing us the actual number of each atom in a molecule, one molecule at a time. Now, for example, let's take another one in molecular formula, which is of ethane, C2H6. This is an organic compound. Ethane belongs to the homologous series alkanes. Now here, this has 2 carbon atoms and has 6 hydrogen atoms. So whenever we count all the number of atoms of a certain type of element and write them together, that is known as molecular formula. Now, let's learn about displayed formula. Let's talk about displayed formula. Now, in displayed formula, you are drawing out every atom and every bond in the molecule. So I'm going to take the same example of ethane above, which is C2H6. Now, I'll start by drawing out the 2 carbons. And remember, because carbon has 4 electrons in its outer shell, the maximum number of bonds it can make is 4. So when I'm drawing out the carbons, I've already drawn out one bond between carbon and carbon. So I'm going to draw the bond numbers in green. So carbon and carbon, they've got a bond each. Then if you start counting each bond your carbon has, whenever you're learning or if you're new to drawing displayed formulae, it is always better to count the number of bonds your carbon has. It cannot exceed more than 4 bonds for each carbon atom. So in that way, you're very sure that you're drawing the correct displayed formula. Now, each line represents a covalent bond, a shared pair of electrons. And once again, at the cost of sounding being so repetitive, always show all 4 bonds for each carbon atoms. Right? So that's a displayed formula. And now we will move on to structural formula. Now, when I'm explaining the structural formula, I want you to go ahead after this, pause and practice a couple of compounds, drawing both the displayed and structural. Now, pay special attention here. For example, let me first draw a displayed formula of propane for you. So for propane, prop is 3 carbons. So I have drawn out the 3 carbons. Now I am building up my hydrogens and making sure I'm drawing all of my hydrogens here. Now, once I am done with my hydrogens, I am going to write my molecular formula. So 3 carbons in propane, that is C3, and H8. Remember, in alkanes, you will always have twice the number of carbons plus 2 extra hydrogens in the molecular formula of an alkane. Why? The general formula for alkanes is going to be CnH2n plus 2. So each homologous series you're learning will have a general formula. So general formula is the pattern. Now N stands for the number of carbons. So N stands for the number of carbons. And in this example, we are looking at propane. So therefore, we have 3 carbons. For GCSEs, according to your specification, be it whatever, the maximum number of structural formulae you need to know how to draw in any homologous series is up till bute. That is, for example, in alkane, you need to know methane, ethane, propane, butane. But to get that grade 9, I would definitely recommend learn your carbon prefixes up until 10 carbons, because sometimes in the question paper they can give you questions based up until 10 carbon molecules. So it is always useful to clinch that grade 9 in chemistry to have that extra bit of knowledge. But according to your specification, you're required to learn only up until butane. Now, in structural formulae, if I'm sure that you all have played with Legos. So you build a Lego toy brick by brick. Now, when you're dismantling it, you're doing the same. Now, a structural formula is something like it tells you how to build the displayed formula. But here I'm going to build the structural formula from the displayed. It can be done vice versa. Now pay attention, fams, here. So I have drawn the circle around the first one, which is CH3. Then I'm drawing the circle around the next bit, which is CH2, and then I'm drawing again the circle around CH3. Now, can you see here? So if you look at the screen, I now only have CH3, CH2, CH3, which is the structural formula for my propane. Okay, so if you look at it, I can similarly look at the structural formula, have my first carbon, and draw 3 hydrogens. And then the second carbon, and then it has only 2 hydrogens. And then my third carbon, it has 3 hydrogens. So it is very easy to build displayed formula from the structural and structural formula from the displayed. And I hope it is now clear what is molecular formula, what is displayed formula, and what is structural formula. Now, what I want you to do is pentane, hexane, and septane. I want you guys to go ahead, draw the displayed formula for these alkanes and the structural formula and post it in the comments. Then I will tell you if you have done it right or not. Alright, then that's it in this video, and I'll see you in part 3, where I will be talking about more of alkanes and alkenes. Bye-bye.